troubleshooting HSRP, VRRP, and GLBP. The acronym soup of protocols that I just mentioned all fall under the broad category of first hop redundancy protocols, or what I like to call default gateway redundancy protocols. Whether you're using direct routers or layer 3 switches, all of these devices on the LAN will have a gateway that they are assigned to point to, whether it be statically or via DHCP. Now, if that device fails, then you have to go around and change the default gateway on all these devices. Again, whether it be DHCP resetting all the switches so they get new IP addresses. You don't want to do that. So FHRPs come in allowing you to create a virtual IP address and MAC address, which immediately deals with the ARP cache issues, because these guys remember the MAC address of the device that they were previously using, and if you don't have a virtual MAC address, you're going to have to wait 5 minutes for that cache to time out and it to ask again via ARP entry. So we virtualize the IP address and MAC address, and one or both of these routers could respond. Now I say or both because that really depends on what protocol you're using. There's differences between those three, HSRP, VRRP, and GLBP. We'll talk about that in a second. The client should never know this happens. Now, this is not stateful. Can I make that point? A lot of people start getting used to stateful firewalls like the ASA, where you have a replication link between them and they're replicating the NAT table 100%. So when the firewall fails, bam, it can fail over and nobody knows. Streaming sessions go uninterrupted. It's amazing. This is not stateful failover. So that means when a failover occurs, if you're watching, we'll say, a streaming YouTube video, you may see the stream stop and you have to, restart it again. Or I've seen, for instance, instant messengers may log out and log back in because they lose their session with the server and realize they have to reconnect. So again, minimal. It's not like a major impact, but it's something to be aware of. How fast does failover happen? That really depends on which protocol you use and how you tune the timers. Now, big question, what if the WAN link fails? I mean, we've been talking about this virtual IP address and MAC address. Well, all three protocols support something called interface tracking. You can do it either based on the line protocol, like if the line protocol goes down, this guy can lower his priority so the other one ends up taking over as the master device, or you can even do it based on something like IPSLA, where these devices send a ping once every second or 2 seconds to some trusted address out there, and if the ping begins to fail, it also considers that down. Okay. Let's look at the protocols themselves and establish the common ground between all three of them. All three first hop redundancy protocols are focused on redundancy. They all use a virtual IP and MAC address, and they all use keep alive timers to tell if the other device is down. It's like a routing protocol does, right? So if that's the case, what makes them unique from each other? Well, HSRP's unique feature is that it was. It was first of the game, and Cisco was the one to create it. So its unique feature is that it's Cisco proprietary, and nothing else existed for years after this thing was created until the industry caught up with VRRP. Now, before we leave HSRP behind, I would still say to this day it is probably the most popular protocol in Cisco environments, simply because Cisco created it. But VRRP came out many moons after HSRP and has some notable features. One is that its keep alive timers are faster out of the box. By default, HSRP says hello once every 3 seconds and considers the other device dead after 10 seconds. Whereas VRRP says hello once every 1 second and considers the other device dead somewhere around 3-ish seconds. It uses a little algorithm to determine which device takes over. So it's faster. Now you can tune HSRP to be that speed or even faster than VRRP. Both of them support taking the timers into the millisecond level, which gives you that super lightning fast failover. But again, it's just notable out of the box, VRRP will be faster to converge. The second thing, and again, it's not a big deal, but I have been in a specific situation where this bailed me out. VRRP can do this with 2 IP addresses, meaning you can actually assign the virtual IP address as the IP addresses of one of the devices. Whereas HSRP, you have to have 3. You have to have 2 unique IP addresses and then the virtual. Now, for the record, I will say I like this method much better. I like having a unique identity that I can get to these devices separate from the virtual IP address. But I've been in a situation where I'm sitting at a data center. I've got a couple routers connected to a switch, and that goes to a couple routers on the data center side. And so we've got the IP1 and IP2 of the data center devices, and they use a virtual. And IP 3 and 4 of these guys, and then there's my virtual IP address. And we've got a /29. Right? It's a public subnet, which gives you 8 IP addresses, but only 6 of them are usable. Well, you tapped it out using this. In the situation I was in, I needed 1 more IP address on this LAN for the switch between these devices. I wanted to assign a public IP address to the switch. I know some of you are like, "What? You're crazy for doing that." Don't judge me. You don't know my situation, right? I needed to assign a public IP address to the switch so I could monitor and get to this switch, bridging the 2 remotely. And so I was stuck until I used VRRP to eliminate one of the IP addresses, and then I could do it. So again, very specific situation, but it bailed me out. So otherwise, these 2 protocols are virtually identical, right? GLBP is the unique one. Now we are back into the Cisco proprietary land. This is for Cisco only devices, and this is the one that implements an active-active model. These other 2 devices always use an active standby model, so one device sits there idle until the other one dies, right? GLBP picks an active virtual gateway. One of these devices will assume that role, and it will actually elect multiple virtual MAC addresses. So you have MAC 1 and MAC 2, and what happens is as the different devices on the LAN ask for the MAC address of their gateway via ARP messages, this guy, the active virtual gateway, will dole out different MAC addresses depending on what load balancing scheme you've set up. You can say, well, I want to do a 50-50, so half the ARP requests get this MAC address, half of them get this MAC address, or you can weight it one way or the other. I mean, there's many ways that you can load balance, but the end result is you end up with an active situation, and you can utilize all the bandwidth and the capacity of both devices. As we start talking about what can go wrong, I put some notes and show commands up here on the board to think about, but I think just showing you the setup of this and then showing you what can naturally happen will really give you the big perspective of this. So I've got a GNS3 topology that I use, just really basic. You can see router 1, router 2 sitting there on the screen. Up top I've got the 10.1.1 subnet, bottom 10.2.2 subnet. I assign this guy to the .2 and .3 respectively. You can see each one of these because I'm going to make the virtual IP address .1. I'm going to do this just using, again, basic HSRP to start off with, right? So let's bring up router 1. I just booted this guy up. Do a quick show IP interface brief. Make sure I've got all my IP address right then. Hang on. Alright, that should fix it. Let's do a show IP interface brief. Or BRF. And I've got my IP addresses going on there. I'll do a show run interface fast Ethernet 0/0. Nothing underneath there. No HSRP configured as of yet. Let's just double verify router 2 real quick. Show IP interface brief. Looks good. Show run. And there we go. Okay, so we're looking good. I'm just going to do a quick ping. Make sure everything is working right between these 2 routers. Good. Now let's get the PC configured. I've got this PC which is going to be set up for the .50 address. We'll do a show IP. Right now he's not there, so we'll do a IP 10.1.1.50/24 with a gateway of 10.1.1.1. Right? It's going to do its little check. Let's do a quick ping 10.1.1.2. There's router 1, router 2, and HSRP not getting anything right now. And since his gateway is set to that, he's not going to get off his subnet. So let's get PC2 jamming first. Let's do a show IP here. I don't know why it's not keeping my IP configurations. IP 10.2.2.50/24, 10.2.2.1. Check for the duplicate. We'll make sure this is, again, just base setup, making sure that our scenario is good to go and we're not troubleshooting anything that we're out of the scope, if you will. So we can get to router 1, router 2. Good. Okay. Let's get HSRP set up. We'll bring router 1 back into the picture. You'll see just how easy it is to set this up. I'll do interface fast Ethernet 00. I'll do standby IP address 10.1.1.1. Now again, this is the one sitting there on, let's just grab my pen here. Sitting here on this subnet. So we're going to have the virtual be that .1 sitting in the middle. That's what that guy running off the bottom of your screen is set to do. So we'll get him going, and well, let's give him a higher priority. Priority, I'm thinking, not priority group. Standby priority, we'll make him 110 because the default standby priority is 100. So let's then, while we're here, let's go to the other side. Interface fast Ethernet 0/1. Standby IP 10.2.2.1. Right, standby priority 110. So we're getting HSRP running on both of these. Now, I know some of you might think about the standby group. This adds a lot of confusion. Hey, group number, I thought you have to use a unique group, because if you don't specify a group number, it actually uses group 0. Check it out. I'll do show standby. And this is something that a lot of confusion, I've seen a lot of people talking to me about HSRP get confused about. They're like, well, you can't use group 2 on both interfaces. Actually, yes, you can. Works totally fine. You can see fast Ethernet 00, group 0, fast Ethernet 01, group 1. You can actually have, what is that? Looney Tunes, right? You can have 256 groups per interface, which that's why I want to emphasize that. So it makes it so crazy when in HSRP version 2 they're like, hey, we've made this 4096 groups per interface. I'm like, good grief, what kind of maniac are you? Because you can use the same group number on multiple interfaces. This is just if you want to do multiple groups under the same interfaces. So anyway, if you type in standby with nothing, you're group 0, and we're actually running now, right? So now I can hop over to that PC number 1, and let's ping 10.1.1.1. Yep, we're good. Reply, and let's go through to the other side. Let's do 10.2.2.50. Good. So we're actually looking at the topology, pinging now using HSRP through router 1. I haven't even configured router 2 as of yet, to PC2 and back, right? I'm going to emphasize that back as we start getting into the troubleshooting. Let's do router number 2. Did I say router 2 or PC2? Global config mode, interface fast Ethernet 0, standby 10.1, or standby IP 10.1.1.1, right? That'll be this side, and that's going to default to the priority of 100, which is all good. You know, that's fine. It takes a little a bit for it to come up. It's just kind of going through its boot cycle right now. We'll go standby fast Ethernet 0/1 2.2.1. Let's do a quick show standby. Right? Show standby. You can see group 0 happen. It's in state of listen right now. It hasn't gone active. This guy's in a state of init. Oh, hang on. Interface is down. Yeah, so in it, it's not communicating at all. I was thinking I forgot to do a no shutdown, but I didn't. You can see it's now gone from speak to standby, which means it's sitting there recognizing that there is an active router over here with the priority of 110. Okay, right. So base setup, life is good. Verifying once again that PC 1 can ping on through to PC 2. Yep, we're good. So let's break something, right? I'm going to go over to router 1 because we're thinking, all right, HSRP, this is good. You know, with router 1, I'll do a show standby. This is the active router, right? Priority 100. Standby router is 10.11.13. So, I mean, it's like, okay, ooh, this feels good. Yeah, okay. So I'm going to do a global config mode, interface fast Ethernet 0/0 shutdown. Bam. We just took down, what did we do? We just went in, get the red pen out, and killed that interface. So now this guy's going right here. He's like, bam, hitting the wall. But, hey, we just shut that down. This guy should take over, right? Right? Well, hang on. Before we do any testing, let's make sure HSRP is working as advertised. And, yeah, it is. We see router 2 immediately went from standby to active. Okay, good. So this should be good, right? Let's ping through to the other side. Look at that picture. Pause me right now. Pause me. What's wrong? Why am I mean, this should have all gone through and worked okay, right? All I did was shut this down. We saw this guy take over. What is wrong? While you're thinking about that, let me jump back here and just give you the quick FYI. Timers move fast if you shut down. You may have saw when I did the show standby, we've got the hello time once every 3 seconds and hold time once every 10 seconds. If you're doing this or you're going through Keith Barker's labs or whatever you're working with this on, which I highly encourage, you'll notice when you do a shutdown like this and you take down the interface, it's like, bam, failover happens right away. You don't have to wait that 10 seconds because it actually sends a goodbye, shutting down message to the other side, causing an immediate transition. It caused me so much. I'm like, man, this is moving too fast. It's a good thing, but I thought, so timers do move fast if you shut down the interface because it doesn't use the timers at that point. Okay, so what's wrong with the picture? Any ideas yet? Why are we going down? Well, let me give you the answer. What happened was I just went in and shut this interface down, right? This guy, where's his default gateway pointing to? Right there, right? Now, here's the key. I did a base configuration, nothing fancy on these routers at all, meaning I have no routing protocol set up. If I would have set up a routing protocol, this guy would be like, oh no, my connection to 10.1.1.1 is down. Let me get a new route because EIGRP, RIP, or OSPF, or whatever you're using. This guy would be like, hey, I've got an alternate route because you lost your route, right? But I don't have routing protocol set up, so he's just like, sorry. So when this guy's coming over here to router 1, he's like, I can't get there. Drop. So the fact is, it did fail over. I mean, if we wanted to do a true packet flow, right? It did fail over. This guy's pings, I mean, whoosh, this guy's gone, right? He's now going this way, and if I were to, do a debug and see packets, this guy would be receiving it, but when he's going, HSRP is still active over here, right? You get this, right? So it's getting here and going dum, 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 dropping. So how do we fix that? Well, A, you can set up a routing protocol, or B, we can use object tracking. Object tracking allows HSRP to make decisions based on track objects that you set up. Now, HSRP is awesome because it makes it so easy. Hang on, let me just do a no shutdown, get our connectivity going. I'm going to go under, let me get my topology. I'm going to go under this interface right here. And I'm going to set up object tracking to say, you know what, if this interface goes down, I want you to subtract, let's just say 20 from your priority, which is 110 right now, and have the other guy, take over, right? Right? Well, now there's even some troubleshooting there. Watch this. I'm going to go in and go into Fast Ethernet 0/1. We'll do standby track. Now VRRP, GLBP, they kind of force you into using track objects where you define a track object, which is kind of cool because you can set up SLA where it's doing pings, and if the track object fails and all that, you can fail over. But I'm just going to do it simple right here. Standby track, and we'll do Fast Ethernet 0/0. And we're going to say if Fast Ethernet 0/0 goes down, decrement by 20, which when we look at the priority, I'll do a show standby brief. You can see that I right now am sitting at priority of 110 on this. This guy, now here's the catch. Notice this guy's in a state of standby. What's the deal with that? Oh, not PC2. I went router 2. Why is router 1 in standby on here? And if I do a show standby brief on router 2, it shows him as the active. Why is that when we've got priority 100 and priority 110 sitting over here? The reason why is because I haven't set up preempt. Remember preemption? And this is, I was going to let this flow into another troubleshooting scenario with PC1, but let me just solve this one right now. Because the deal is, I could set up object tracking all day and be like, okay, if this goes down, subtract 20 from your priority. But if you don't set up preemption over here, this guy's going to be like, oh, looks like your priority went down, my friend. That's nice. And he won't actually do anything about it. Preemption says, okay, whoa, your priority just went down to 90. I'm 100. I'm kicking you down. Sit down. I'm king of the hill, and I'm going to take over those connections right now. That would be another troubleshooting point of failure, is if you don't have preemption set up. So let's go in and configure that all over the place. Router 1, interface, Fast Ethernet 0, standby, preempt. That's it. Interface, Fast Ethernet 0/1. And we should see, by the way, just by typing that one command, it's like, hey, oh, there it is. Taken back over on active because I am the king of the hill. Standby preempt on that side. And we want to do that. And now you might be saying, why would you do this on the backup router, right? Well, because if this guy's subtracting priority, do I talk too fast? If this guy's subtracting priority from himself and goes down to 90 because there's a failure, then you want the backup to take over. So that's why we need the preemption. Standby preempt. Interface Fast Ethernet 0/1. Standby preempt. Good. So we've got that on both sides. Now, okay, this will be good, right? So now let's get PC1 going on. We'll throw him up in the corner here, do a little ping action, and we'll do dash count 5,000. I'm telling you, this will be, okay, good. What's going on now? Okay, so it just took a sec to go through. Okay, we're going through what's happening here. We've got router 1 as the active router. Let's break something. I'm going to go in Fast Ethernet 0/0 and do a shutdown. Bam, we're down. Look at this guy. Got a drop, and then boom, just keeps on flowing. Again, remember, we don't have to wait that time out because shutting down makes it go active right away. So now we see preempt take over on both sides. So router 2 truly becomes the full active router on each side of the connection. Only other piece I'll emphasize is you want to be able to pull these MAC addresses out of a lineup. So GLBP, the initial digits of the MAC address are 0007 B400. VRRP, you can see it right there, first 6 digits. HSRP, first 6 digits are there. So that way you're able to tell which protocol is being used from the client perspective. Let me pull up PC1, which is still pinging away. I'll do a show ARP. And you can, that's not good, ping 10.1.1.1. Why is it empty? Show ARP, that must be, I'm like, it's somehow getting through to that guy. So anyway, I see the ARP table 0000C. That immediately tells me, just by looking at it, that I've got HSRP running. I know on the T-Shoot exam this is relevant, but also in the real world, sometimes I'm from the client perspective, I don't have access to the Cisco devices doing some troubleshooting. And I'll do a quick show ARP command or ARP-A on a Windows machine and immediately know, okay, they must be running HSRP here, so maybe it's related to this, and I can make suggestions without even knowing the configuration that's going on. That should give you a good perspective of what to look for when you're troubleshooting HSRP, VRRP, and GLBP. I used HSRP to demonstrate, but you saw the commands for VRRP, GLBP are virtually the same. I hope this has been informative for you, and I'd like to thank you for viewing.